Hi, welcome back to the shop. This is Shoptalk number 9 for November 2015. This is kind of a loose ends episode. I have a minor project that I want to show you. Follow up to the teardown of the vertex dividing head. A bigger project that is about to start, and yeah, I will show you some progress on the steam engine I'm building right now. So let's get started and take a look what we have. Okay, we're over at the engraving machine, and I have the vertex rotary table set up on the table in vertical position, and we're right now engraving a dial for this is a job for somebody out of an online forum. He's building a model of a big safe, and this is the dial where you select your combination. And he wanted a dial with 100 divisions around it and numbered from 0 to 99, and I volunteered to do it for him. It's a pretty interesting job, and what was pretty challenging because the numbers are very small. But why I'm showing this is the fact that I had to order the index kit for my rotary table. I didn't have the index plates because I had no need so far for them, but I ordered the kit, which came with 3 of the indexing plates and the indexing finger and the sector arms here, and everything is easy to set up. You just pull off the hand crank, you screw on the dividing plate, and you screw on the index finger, set it up to the right ratio, and off you go to do your indexing. These are the 2 other indexing discs. They go from 15 holes up to 49 holes, and that gives you a wide range of possibilities with the divisions you can achieve on your part. The dividing head itself is 90-1. That means 90 revolutions on the crank make 1 turn on the table. And right here you should be able to see the graduation. We have 100 divisions, and every second line is shorter than the others, and the numbers are staggered. The long lines are even numbers and the short lines are the uneven numbers, and that's 360 degrees around. So I had to cut the 100 lines and 100 numbers, and I do all the even numbers on the longer lines and all the uneven numbers on the shorter lines at once, so I don't have to move the table in Y direction all the time. I engraved the lines with a rotary single lip cutter because of precision, and for the numbers I'm using my carbide spring-loaded drag engraving tool. I showed this in another video where it made me some problems because it's not super accurate, but in that case we're just engraving numbers for a dial and not doing graduation work with it. So for that job it's perfect. And as we have to do 100 divisions, we have 3.6 degrees between each line, but we do every second line only. We have to divide it to 7.2 degrees. Then we offset it by 3.6 and do another 50 lines 7.2 degrees apart. Hope that makes sense. Here you see the indexing plate, and I have different colors on certain holes. The blue holes are for the uneven numbers and the red ones are for the even numbers. That's just a little helper for me so I don't accidentally miss a hole by 1 or 2 positions. That might suck. And the operation is pretty simple. We want to go on to the next position for the number. We want to this is a 20 hole circle I'm using here. Each revolution of this crank gives me 4 degrees on the table, so it's 4 degrees divided by 20. That means each hole gives us 0.2 degrees, and we want to proceed on 7.2 degrees, so it's 7.2 divided by 0.2, and that's 36. That means that we have to crank 36 holes. Of course, as this is a 20 hole circle, that's 1 revolution. Wrong direction. This is 1 revolution plus 18 holes. 16 holes, sorry. And to make it easier, the selector arms or sector arms here show you where to go. And after you dialed it in, you just move it over. Then we do our engraving. I have this beautiful numbering template where we can engrave numbers up to 7 digits. Very easy. You can just press this pin and push it on, so you can get numbers from 0 up to 9,999,999 just by moving these sliders in and out. And you don't have to change your templates on the table all the time. Unfortunately, I couldn't use this for this job because that's a wide font, and space on the dial between the lines is very little, so I had to do it another way. I had to turn the template table of the engraving machine by 90 degrees, so it's lined up in that direction, and then I had to use single templates in a narrow font and had to set up every number individually. So now it's set for 93. I pull out the 3, I put in the 5, slide in a lock block or stop block, and get our stylus in the template. Now we go down to the spindle and watch the actual engraving. Okay, we have the right position by the dividing head, we have the right template, so let's drop the engraver down. And do our this is a 9. Now we go over to the 5. And I like to run the engraving tool more than 1 time through the engraving. That gives a better result. Now we can pull the tool out of the way. And we have our 95 engraved. I swung the camera around here, you can see it quite a bit better. The drag engraving tool leaves a bit of a burr, but with some super fine emery paper, which in this case is 3M super finishing film. we can knock down these burrs and we get really a nice clean engraving. There we go, that was number 99. And I held it just in a Morse Taper 2 ER16 collet chuck that I jammed into the Morse Taper 2 socket of the rotary table. Let's open the collet nut and take a look what we have. And I think we have a pretty good dial there. It's a bit hard to film this because of the glare, but to me it looks pretty good. And it's just screwed onto this arbor with a single central screw. That's the dial. I have also to engrave another part which will be the vernier fitting to this, but I will not show this on camera because it's essentially the same, only with a different graduation. So that's the index disc set for the vertex rotary table and some engraving. Okay, next thing in this episode will be my Offcenter chuck. I made this for the small steam engine because when I machined the crank for it, I had really a pain in the ass setup on the lathe, and with some helping jigs, and it was really not that great. And I designed and built this special offset chuck for my lathe to do offset work. It consists of an Keats angle plate, where this is a very common design in model engineering. I think it was stock accessory for the Myford lathes, and it's normally just bolted onto a standard faceplate, but that's a bit of a pain to set up. And what I made is I made a special small faceplate with a single T-slot, and the angle plate is keyed into this slot. That way, when you loosen the single bolt up here, you can move and set your offset set your offset or your runout that you want on your eccentric piece. Very easy. Lock it in position and you're good to go. And I have some footage where I show this on the lathe setup. I will show it right now. Okay, and we're back. I will do a complete video on this, or a semi-complete. I don't have a full build video on this, but I will show some of the making of the angle block and how it's used on the lathe. So watch out for the video if you're interested in stuff like this. Next thing I wanted to show you is this is also kind of a teaser. This is a Zeus cut knurling tool. This is a really high-priced tool to make straight knurling, and it's not a forming tool, it cuts the knurl. So it produces, even in very brittle materials, a very clean knurl. And I did some test knurling in brass. And you see that the knurling is really very well formed out and pretty crisp, and I like it very much. I had this tool only for testing in the shop, and I decided to keep it because it gave me that nice result. Works also in free cutting mild steel very well. And the straight knurl is, sometimes it looks a bit nicer than a diamond pattern knurl. So I will also do a video on this tool. And they are not that complicated to make yourself, but I wanted to, I can't build everything myself, so I just bought this one. You might remember these are the saw arbors I made some time ago, and where I still have not uploaded the second video. I'm also making some bigger saw arbors for 16mm board tools with a Morse taper too, and I have a video upcoming where I do where I show the setup and turning of the Morse taper 2 with the top slide of the lathe, which is on a small lathe the only method to cut a Morse taper, because most of the small lathe don't have a taper attachment or a tracer attachment. So also look out for these. And yes, there it is. The Simplex 1-cylinder steam engine, and nope, I'm not finished yet. I did off camera the crankshaft and the con rod, and I machined the sliding valve and the valve rod. Valve rod might be the term. And it's not much work anymore. I need to do the Offcenter, which controls the valve, which I will turn on the Offcenter chuck I made. I have to make the valve cover and do a lot of small parts, but it's getting somewhere. And we can pull off the A-frame. Then we can take a look at the crankshaft, the con rod, and the crosshead. Let's pull off the bearing blocks also. Nothing is bolted down, so I have the crankshaft machined out of one piece. Sorry, I don't have a video on that. This was a bit, I was not in the mood to film it. I have the con rod with the split bearing down here, and the connection to the cross guide up here. That's it. That's not much more. But I have some more videos on the steam engine, of course. Don't worry. And this is a real long-term project of mine. The Deckel G1L engraving machine I showed earlier, where I did the engraving of the dial, has a spindle which takes special collets, which nobody uses. And I made a replacement spindle which takes standard ER11 collets. My spindle I built was only a prototype, nothing was hardened or ground, but I had somebody to make me a set of housings. These are hardened and ground from carbon steel, and they are just beautifully finished. They are ground on the outer diameters, and the two bearing seats are ground. And also this inner diameter here is ground to a very fine finish and very close tolerances. And I have some pictures of them, or video clips of these when they were made. They were turned on a CNC lathe, then hardened in his shop, and then ground on a beefed up universal grinding machine. And I'm quite happy how these came out. It was not cheap, but it was well worth the money, and I will build 4 of these spindles. I will keep at least one, and I will see what I do with the other ones. And in these blue boxes is the other part of the spindle. These are ER11 colored chucks with a straight shank, and these will go into the spindle housing with bearings. Then I will machine the pulley on front, and I have to do some smaller parts for these, and this will be quite a big project because it's a lot of parts to make still. But the hardened and ground housings are the most important step for me right now, because I couldn't make these in-house. Okay, that was a brief wrap-up of the loose end projects I have right now in the shop, and I was quite surprised how well my Q&A video impacted on as I released it, and I thank you all for watching, and especially commenting on the Q&A video. That's quite a heads up. Thank you all. And by the time this video goes online, I'm really scratching the 6,000 subscribers, and it's quite surprisingly what you can do with a video camera, internet connection, and some machine tools in your basement. How many people you can reach, and how much stuff you can share and learn and show and tell and whatever. So yeah, great thing. Thank you all for watching. See you next time.